Hello everyone. Today we are going to look at how we can install Litmus, all the features surrounding Litmus 3.x, how you can pick multiple faults and create entire experiments through it, and also how you can use those to create or inject chaos in your applications. To get started, I have a GKE cluster which has 3 nodes in it. I don't have any Litmus namespace as of now. I just have a demo namespace where my application which I will target is residing, which is nothing but a boutique online application, a microservice demo application, which I'll talk about in a minute. But yeah, so as you can see, my cluster is completely empty. There's nothing as a starter template or anything to bootstrap it with. And now I'm going to install Litmus on top of this. To get started with Litmus, you can go to the docs.litmuschaos.io and you can select the specific version you want the installation of. For this case, I have selected master and I've switched over to the getting started installation section. So once you are here, you will get all the different cluster scope and namespace scope installation instructions. So currently I want to install Litmus using kubectl, I can directly jump here, but if you want to use Helm, you can of course scroll up and use Helm as well. If you want to follow along with me, you can install Litmus using kubectl. You can see the instructions given here as well as in the GitHub repo. If you go over to the GitHub repo, the first thing you want to do is install Mongo with high availability, which is why we're using the Bitnami Mongo. I'm just gonna copy the command and apply the same. Next, I will apply the Mongo values provided to me in the Helm itself. You can use this, you can save it somewhere, or you can just copy it from here. For me, I've already pasted or saved it somewhere in my local system, so I can apply it directly from there, but I'll still copy this and update the command. So in my case, I have my values stored in this specific folder, and the namespace for me is Litmus, which I've selected here. Alright, now that Mongo is created, we can go ahead and watch the status of the pods. Alright, now you can see the HA setup for Mongo coming up. We'll leave it to that. It'll go ahead and create and set itself in the running state. We'll just minimize this and come back to our installation. So now that we have done the Mongo setup, we can go ahead and apply the manifest. I will click on here. This is the cluster scope installation. You can also go ahead and update it via a namespace scope installation. But for now, I'm going to select the cluster scope. I will go back and apply the same. Now right now it's creating all the RBAC permissions, the cluster rules, another dependency that Litmus needs to run, the config map, the secrets, the service accounts, etc. Now that it's done, we can go ahead and do a quick check to see all the services, all the pods up and running. As you can see, they're all up and running. Now in order to access Litmus frontend, you can just check the service in the Litmus namespace, and you will see a front-end service, which is this one. Now you can also do cluster IP and the port, but I would rather update this to a load balancer and check the same. Now that it's updated, let's give it a few minutes for the external IP to load, and then we can access Litmus from an external endpoint. Alright, now you see an external IP has been updated for us. So we can use the external IP and the port to access Litmus. I will copy this external IP, go to my browser, and use the port in order to open Litmus. Now you can see Litmus is booting up for us. It will ask us for default credentials in order to log in. So by default, the credentials for Litmus is admin and Litmus, as you can also see provided in the docs. So you have to provide the username admin and the password of Litmus, and we should be able to log in. Alright, let's provide admin, let's provide Litmus, and try to sign in. We can see that we are now inside Litmus. By default, since we have 0 infrastructures available right now, and we definitely need an infra in order for Litmus to figure out where your applications are residing inside the cluster or inside the namespace, we would need to enable a chaos infra in order for your first discovery and your first chaos experiment run. Now there's a pop-up which is prompting you to do so. You can also close it and do it later. For now, I can select enable chaos. This will navigate me to the environments tab. We'll of course take a look at the other tabs, but for step 1, we'll be creating a new environment. We can give a name to the environment, and then we can choose the type of the environment, whether it be pre-prod or production. Now this step is required or kind of good to have if you want to categorize the type of different chaos infras you're creating, if you want to specify or wrap certain environments, certain infrastructures in a specific environment for ease of use and understanding. For this, I'll go with pre-prod and save. Now I have a pre-prod environment. I can go inside and enable chaos. So Kubernetes chaos infras are the target deployments that are required, that would be synced with your cluster in order to start the discoverability of your applications and where your other services are residing, so that we can target them and do chaos on them. Now we click enable chaos. We give a name of the infra. For this I will say infra 1. I'll go next. We can choose the access or scope of the infra, which is cluster wide or namespace, specific namespace. For this demo I'll choose cluster wide, and the namespace and the service account is already pre-populated for us. You can of course go ahead and change it, and for the advanced option you can choose the node selector and the tolerations in the chaos infra deployment. Let me go ahead and do next. Once I do that, I will have an infra manifest ready for me. I can go ahead and download it. Now basically after you download, what you have to do is just apply this infra to your Kubernetes cluster. Cool. Now that it's downloaded, let me go and click on done. You will see a pending icon starts appearing now. I can simply type kubectl apply with the location of where the manifest was downloaded. In this case it was my downloads folder, and since we already provided the namespace in the modal itself when we were creating an infra, it would automatically pick that namespace, and you don't have to explicitly specify it here. Now since the namespace I chose was Litmus itself, and we already have certain things running in Litmus which I can watch again. So we already have these services running in Litmus. Once I install the chaos infra on top of it, you will see other dependencies popping up which are infra dependencies in the same namespace. Alright, let's jump back to the namespace, and you would see certain things have popped up recently, like the event tracker, the operator, the exporter, and things like the workflow controller, the subscriber. So these are infra dependencies or infra services that are running in the specific namespace that you provided. This does not necessarily have to be the same place where you're installing Litmus, where you're installing all these other services, but for the ease of use and for easier visibility, I've added it in the same namespace as well. Now we are all set and ready to jump into our first chaos injection. Let's wait here a bit so that we can see the infra getting connected. Alright, now that infra is connected successfully, we can go ahead and move on to the chaos injection. Now before moving on to chaos injection, you would see there are a few other properties or features that are available in Litmus, which is the chaos experiment where you can see all the different chaos runs that have happened, and also overview where you definitely get an overall representation of what is going on inside Litmus. And also there's one important thing called Hub. So Chaos Hub is generally a repository of all the different faults that are available as part of Litmus. So you can see there are a few predefined experiments that are pre-configured for you, and there are chaos faults which you can combine and create a single or multiple experiments based on your hypothesis. So you can filter them based on a specific category if you want application specific, or if you want for the category to be node specific or pod specific, so you can do that of course. We also have Kubernetes specific or managed service specific, so those kind of things you can target via the help of faults that we provide as part of Chaos Hub. If you, for some example, want to extend on it and want to create your own faults, you can do so using the Litmus SDK, but that's a different topic altogether. Now Litmus also provides something like a teaming feature where you can add new members in the Litmus project, and then you can manage your team inside of a single project. So you can give certain people certain permissions of editor or read only, things like that, so that you can easily as a team manage the entire project from a single plane. If you also want to use Git as a single source of truth instead of Mongo, you can of course opt for the GitOps model, where you can choose if you want to run it locally in Litmus, which is the default, versus if you want it to be a specific Git repository. So then you can provide your URL. If it's a private repo, you can provide your access token and SSH key. If you also want to provide your own images and not use the default images which are provided by Litmus or which are in the Chaos Hub repository, then you can use your custom values via this, and you can choose your registry and the repo, and also the type of the registry. Now moving on to resilience probe. Now resilience probes are pluggable checks that can be defined within your Chaos engine and from within your Chaos experiment, which can be induced. It's a write once, use anywhere paradigm, which is basically you create one probe globally and then you can use it in as many experiments you want it to. And this helps with the assessment, or if you want to add more checks or more assessment on top of what you're already doing via your faults. For example, we can create a new probe. Let me call it an HTTP probe. And in this case I can create a check health probe. Maybe I can give it a description: checks if the demo app's URL is healthy or not. I can give it a timeout of 180 seconds. It can have an interval of, let's say, 2 seconds. I will try to do it once. For the URL, I would specifically pick the URL of my demo application, which is this guy. And for the method, I'm going to select get, and the criteria would be equal to 200. So it's basically checking if this URL is up and running or not. You can of course drill down into specifying the specific FQDN link as well, or specifying a certain external endpoint that you want to provide as well. But for this demo, I'm just gonna specifically choose if and check if this endpoint is healthy or not. I'm going to set up my probe, and there you go. Resilience probe is set up for you. You can click on it, and you can of course check the probe configuration that you've just created. Now, as of Litmus 3.0, it is important and mandatory for you to configure at least one resilience probe in order for your Chaos experiment to be executed. Now let's finally go to the Chaos experiment section. So let's go ahead and create a new experiment. We're going to call this cart service kill experiment, and for the infrastructure we'll be selecting the infra 1, which is the one that we created at the start of the demo, which is also residing on the Litmus namespace like we configured. Now next we go and click on next. Now next we click on next. So we are presented with a few options. You can choose upload YAML. If you already have a pre-configured YAML, then you can directly paste it here. You can choose certain templates from the hub, which is what I already showed you when I was showing off hub, which is the template that are pre-configured in hub, like Bank of Anthos, node level experiment, pod level experiment, potato head, stock shop, etc. And you can also go for blank canvas, which is basically you're starting from scratch, which is what we'll be selecting today. Now before I jump into selecting faults, I want to show the demo application that we already have. So we have a microservice demo application by GCP, which is online boutique store, where we have our front end and all the other services that are connected as a part of it. And we have this cart service, which is connected to a Redis cache. Now it looks something like this. So we have our service in the demo namespace, which would look something like this. So we have our cart service, checkout, and all these other services. So if I describe this cart service, you will see that there's a specific label. There's a specific label app equal to cart service, which we can choose to target this specific service. Now, if you want to target everything, then there's also other labels, or there's other ways of targeting it. But for this demo, we'll be narrowing our scope down to just targeting the cart service, so that we cause intentional disruption. And so that's why we are targeting this specific selector. Now we have already exposed our app through the external configuration to the external URL, which is running here. So this is the online boutique microservice demo application, and this is the cart service. So right now, let's say I want to add some sunglasses, and I click on add to cart. You will see that the cart service is up and running like it's supposed to. So we will be targeting the cart service, and we'll see chaos happen, and this service should not load. So that is the hypothesis we want to create. So that is what we have in our mind, and we want to create it via the Chaos Studio or using Litmus. So in this template from scratch, we are going to add a specific fault, we are going to drill down to Kubernetes because this is our use case for now. We can select pod delete. We can also go ahead and configure these other ones if you want to, but we're going to select pod delete. We can select the app kind. In our case, it's a deployment. The app namespace is demo, which is where our application was residing, and the app label is app equal to card service, which we can select from here or from the YAML itself. So let's leave that for YAML. In the tune file, you can of course override or configure the chaos engine specifications. You want to increase the chaos duration or decrease it, if you want to control the interval, things like that. So you can add tunables on top of your faults if you want to, using the tune file section. And the probe is where you have to select at least one or more resilience probe. So that is a requirement which is mandated for Litmus 3.1 above. So this is the check health probe that we created, which is basically checking the specific URL is healthy or not. You can add this to fault, apply changes. So there's a certain mode that I configured along with it. It's basically SOT, EOT, things like that. So let's say I do this once more. You can see these are the different modes that are available. So SOT is basically will test it at the start of the chaos check whenever chaos injection happens. EOT will check it after chaos injection happens. Edge would be both start and finish, continuous is continuously, and on chaos is when specific chaos is happening. So you can select the mode of execution for the specific probes that you are configuring, and once I'm done I can apply changes. So once I apply change, you can see the fault actually get created on this Chaos Studio. And if I go to the YAML view, you would see all these different configurations that we created from the UI are actually put up in the manifest. And you can see the specific tunables are here, and also the namespace, label, everything is here. Now I can edit the YAML, and I can add the label here as well, which was app equal to card service. You can of course do it from the UI as well. I just want to show you both the cases. So you can add app equal to card service from here like this, and you can save it. So once you have saved successfully, you can go ahead and run this experiment. So let's go ahead and do that. Let's click on run. A new experiment run has been scheduled successfully. Now we come back to our Litmus namespace, and we will see that the card service skill experiment is started. Now how does the chaos injection works is basically Litmus uses certain helper functions, which we can, if we go to the architecture summary, we can see that this is the workflow. It uses the chaos operator, which does the reconciliation, which checks policy validation, RBAC, and if the application is actually residing there or not. So it will check all these conditions, and if it's successful, it will spin up multiple chaos jobs. And these chaos jobs, there will be a runner which will be spinning up multiple chaos jobs, and this runner is what's responsible for spawning up these initial small chaos injectors, which will be actually doing chaos. So you can see there's a runner that's spawned up right now, and this runner would actually be spawning up these chaos injection jobs. So this is one of the job right now. So now that we know that a job is created, we can go ahead and check the status of our pods in the demo namespace. As you can see, this guy just got restarted, which is the card service. Now let me quickly go over to the online boutique store and refresh, and you would see that the chaos has successfully happened. So the card service is down right now. It is not up and running, which is why it could not reconfigure or connect to the specific service, and which is why your service is down. Now once we come back to Litmus, you can see from the logs as well what exactly is happening at what point of time. You can go to the probes, you can exactly see which probe is being executed, what are the details of the probe, what were the properties, and you can also check the fault configuration which it was configured or which it is currently being ran with. Now let's wait for it to finish, and once it's done, we'll come back and see how the results look like. Alright, now that execution is successful and finished, we can see the resilience score is 100% because our probes passed. Now if we come back to the probe section, we can see that the health check has been passed successfully, and you can also see the status that the URL which we provided did respond correctly with the correct status code expected, because our execution was finished, but now the card service is up and running and back again. So if you go back the demo, you would see that this service is up and ready, which is 1 out of 1. The service is back. Now if this service is back, and if we go back and reload, this should come back up. So that's why our chaos execution was successful. It did break it, but it also came back up. So that's why you can say that this specific service is resilient. Now, of course, this demo is a very simple demo, and this is not really a ideal case where you would want to test something like this. An ideal situation would be much bigger, where you would involve, which would involve a higher latency, a different service, or configuring a hypothesis, which is completely different. But yeah, just to show you how this works, this is a simpler demo for the same. So that's all for the demo. We also have a cleanup chaos resource, which is basically cleaning up or gracefully deleting all the resources that were created as a part of the chaos, so that you get your cluster or your service back as it was without any additional services or any additional resources created as a part of your normal workload. Now if we come back to overview, we would see that one experiment was ran. We had one infra, total number of experiments also one, and you can see the same from the pipeline diagram as well. So that's all. I hope you guys enjoyed. I hope you guys learned a little bit about Litmus, and I hope you are interested to learn a little bit more or explore Litmus on your own time. Thank you.